Let's take a look at the TAS65 steering gear. This is a service manual. It's available as a PDF download, and that will be the best guide in how to perform the service and maintenance of the steering gear. You'll commonly find this steering gear on commercial trucks, and it's used to assist the effort of the operator. So the steering gear has a mechanical portion as well as a hydraulic assist portion. We can see the hydraulic assist lines right here. And these two lines are going to come in from our power steering pump. What we see on the end here is what's called the rotary control valve. The rotary control valve is mounted on the power assist steering gear. And where my wrench is mounted right now would normally have connected to the drive shaft that goes up to the steering wheel. So instead of having a steering wheel, I'm going to use a 12-point ratcheting wrench to show the movement of the steering gear. As we turn this input shaft, what we're going to see is that our sector shaft is going to turn. So I'm going to do that. You can see it just sort of in the edge here of your screen. As I turn the input, we can see the sector shaft turn, and we can see it sweep through. Right here, I've made a mark, and that mark that's normally cut in is actually the center point of the sector shaft and the housing aligned. And this is what's going to be the position you'll put the sector shaft in, this one right here, when you go to disassemble the components, as we're going to be able to get the gear out. But I'm going to continue the motion until it goes all the way against the stop. So now, as if we're continuing to turn the steering wheel all the way until it stops. At that point, you can see that the wrench has bottomed out. There's no longer any ability for me to turn the input shaft, but to find the center point of a steering gear, in case you don't have this already pre-marked for you really pretty, what you can actually do is count the number of revolutions, just about 5. Okay, so just under 5 or around 5 turns of the input shaft is what moves our sector shaft, our output, its full sweep of motion. So that means if we split that in half to about 2.5, let me put my wrench up at the 12 o'clock position. We're going to come all the way, most of the way down. Okay, almost half. Let's make an adjustment. So it's 1, 1.5, 2, 2.5. And so at 2.5, we basically have the center line of our sector shaft lining up to the center line on our cast housing, and at that point we will actually be ready to disassemble the steering gear. So it's really important just to do an operational check, make sure that your steering gear is actually going through its full movement. And then finding that center point, and that's how you'll be able to disassemble or begin the disassemble process. All right, so let's look at the disassembly procedure for this TAS65 steering gear that we have in the bench. So step 1, position the gear in a vise. We have done that. It is mounted in the vise on our workbench. Step 2 would be to unplug any of the plugs that you have. So that will be the hydraulic supply and return lines to the steering gear, as well as the K-strain line up here. So that'll get you as dry a steering gear as possible. And then it says position the sector shaft. So again, we'll take a look at the sector shaft here, and the sector shaft center line should line up with the center line of our housing. Then it's going to tell us to remove the dirt and water seal. Then it says to clean off the sector shaft. So one of the things that happen as this is run in is that burrs start to form. So they actually build up on the splines of these sector shaft, especially if your pitman arm has been mounted and been painted, then it can be really hard to slide this through. It can be damaging. So clean everything off, take all the burrs off. You can use a wire wheel to do that. You can use some emery cloth. It mentions here in step 5, use a fine grade emery cloth. Okay, then the next step would be to tape your sector shaft. And then the next thing is to remove the jam nut. So let's take a look at what that's talking about. On this side here, we have a jam nut that's holding the adjusting screw in place. So what we can do is remove that jam nut all the way off. Okay, and then it says remove the side cover bolts. So I've already broken these loose, so I'm going to remove them here. So now that we've removed the side cover hardware, we're just basically going to give a little bump to the back side, this sector shaft right here. Give it a little bump, just like that. And now what we can actually see is the taper on the sector gear. All right, and so now inside here, we actually see our rack piston. All right, this takes us up to step 10, where we can basically discard the gasket if we were going to rebuild. And now it says remove the sector shaft from the cover. So we can see the vent plug is out of there. And we have now removed our sector shaft from the end cover. We can remove the side cover seal right here. And now you could get in there behind with a screwdriver. You could drive your screwdriver in, give it a twist, and that seal will pop up. You can also get in the back there with a rolling heel bar and put a socket in the bottom, and you can get in there with a rolling heel bar. So it's going to tell us to inspect the sector shaft assembly for damaged adjusting screw threads, so make sure that the threads are in good condition. The retainer must also be staked, so that's this outer ring retainer right here. We can see it staked right there. And the adjusting screw must be able to rotate by hand. So that just means it must be able to turn just like this. So there's supposed to be no perceptible lash or movement. And there is a little bit of play in there. So that just shows us a little bit of wear. So if we had serviceable relief valve components, it would be right here. We do not on this model. All right, the next thing it says is to remove the dirt and water seal. That is this seal right here. Now it says to clean the input shaft the same way we did with the sector shaft before we removed it, to prevent any binding as we take it apart. And now it says remove the 4 Torx head bolts that are holding on our rotating valve group. So up to step 19 then, we can remove the valve housing, worm, and rack assembly. Right like this. So at this point, you'd be able to replace this seal right here on our rack piston. Again, this is going to be the piston surface area where the hydraulic pressure is going to act on to assist the steering gear. So our mechanical input is still going to be coming from our input shaft. So our mechanical input for our steering gear is still coming in through this input, but through this worm shaft right here, this is a ball nut inside the rack piston. So through this guide tube right here, actually a set of ball bearings travels around the grooves that we can see on the worm shaft, and that's what actually mechanically allows this steering gear to operate. So if I grab our 3/4 inch 12 point, we can actually rotate this input shaft and we can see that the ball nut is moving on the input shaft. So the worm shaft is that center shaft. The ball nut of a mechanical steering gear is now replaced with the internal ball nut of the rack piston. And now we can see that as we turn the input shaft, we can move that rack piston position. So this is really using this ball nut system. This is how we turn the rotary motion from the steering wheel into a linear motion at the steering gear. So we're moving this, and now actually this gear is turned back into a rotary motion by the sector gear, which turns the sector shaft, which is now actually going to operate the pitman arm. And again, rotary motion turned into mechanical linear motion by the pitman arm. All right, so at this point in the disassembly process, we are to remove these Torx screws, remove this cap, remove the ball guide right here, and we can actually have all the ball bearings come out. Now, an important piece to do is to count the ball bearings that you get out of here and compare them against the manufacturer's chart in the service manual. There's a steel ball reference on the top of page 29 up here, and since we're with the TAS65, it's actually 32 balls are what we were expecting to find. So when we remove the steel balls, we should count 32 of them. It's also important that when you rebuild this, you count 32 back in. All right, so you cannot, or you should not, rebuild this worm shaft and ball nut assembly without removing the balls, inspecting them to make sure they're round. Although, why would you inspect them? You'd simply replace them. And when you replace them, you're going to count them as per the model number of the steering you have back into this assembly. An easy way to actually remove these balls without losing them, because it can be so easy for them to fall all over the place. A very easy way to remove these balls out of the groove here is actually to remove the cap while it's up. So leave the rack piston in the bore of the steering gear. And it's actually easier if you have a set of guide studs, that you can put a set of guide studs in the end of this housing to align them to the main cast housing of the steering gear, and that sort of keeps your rotary valve in control and sort of lets you stay in control of where all the balls are going to go. But even if you don't have that, you weren't ready for it, you can still just remove this top cap, and I'm going to capture and put all the nuts in the end housing, or actually in the side cover of the steering gear here. But what we do is lift up. You're going to take this trough out, but we're going to actually do it by turning this rack piston upside down. Simply putting your hand underneath it. And unfortunately, I didn't win. One did fall onto the floor. But now what you can do is actually turn your worm gear, or your worm shaft, and push the balls out the hole of the rack piston. And you'll know you got them all when your worm shaft, your input shaft, comes out of the rack piston nice and easily. And if it doesn't pop out, so you can see that I can't pull this out, if it doesn't pull out, then you have not yet got all the balls out of there. So don't pull, don't yank, just keep turning back and forth. One of the balls almost got away on me. So just keep turning this back and forth until all those balls come out. Now this is why having the guide studs to hold this rotating group, this rotary valve assembly in place, this is why that's very helpful, is so that you can actually just turn the input shaft and all the balls will pop out. So there's one more that just fell out, and at that point we can see that the worm shaft comes out of the ball nut assembly of the rack piston, and no damage was done to the grooves. We didn't pull and yank on it, we didn't yard on it, it just came out nice and easy. And now our job will be to count the ball bearings that came out of there. And now you're at the point of inspecting your rack piston, the tooth contact, to make sure you don't have any cracks showing up or forming in the rack piston itself, that you don't have too heavy a gear wear, so the step on your rack piston is not excessive, so you have no cracks, no galling, no spalling, no pitting, no. The other thing you'll want to check is to see if you have any grooves, any scoring on the rack piston itself, to make sure that it would be smooth. Of course, once you're done with inspecting the rack piston itself, you would inspect the actual bore of the steering gear as well. Free of any scratches. We'd like it to be free of rust. So last bearing remaining in here is going to be our needle bearing, our roller bearing, that is supporting our sector shaft in here to prevent it from riding on the seal. And so then as we remove the seal, we'll be able to remove our bearing, and we'll be able to install a new bearing, a new seal, and then we would install our resealed rack piston back into the bore. All right, another major component of our steering gear that we took apart earlier, we got the worm shaft, our input shaft, and rotary valve removed. So now it's time for us to disassemble it, inspect the bearings, and replace the seal. There is an adjustment. This worm shaft, you'll actually, when you remove it, if you're doing this on a used one, a worn one out of service, you'll actually find that this worm shaft, the input shaft, rotates very easily. And now the reason why it's doing that is the bearings have worn, the preload is gone. But your job when you reassemble this is to make sure that that preload, as per the manufacturer, is restored, because this input shaft should be under a preload or under a tension. Now, that is to make sure that you don't have excessive play from the steering wheel through the input shaft, through the ball nut to the sector shaft, and so that you don't have any steering wheel play from the operator's concern. All right, so step one here says we're going to place the valve housing in the vise. We've done that. We are going to unstake the adjuster. Now, these ones have been rebuilt before, but the adjuster stakes are actually the marks right here. So what would normally have happened is the technician would have grabbed a punch and would have hit them and actually locked the adjusting or the lock nut. They would have staked it to the housing. All right, so now we're going to remove the bearing lock ring. All right, so we're going to bring in some specialty tooling at this point. And what we have is a tool that's a ring with tabs that line up to the notches in the lock ring. So what we can do is simply install this. And we do not need the inside tool yet. This is the inside tool right here. All right, so at this point, we put a ratchet on this outer ring here, and we hold our valve in the vise. All right, so once you've installed your tooling to remove the lock ring, use your long breaker bar or long ratchet, install it on the tool, back the adjusting lock nut off, and then you can use the tool to remove it the rest of the way. At this point, that lock nut will come free, just like that. And now you can actually back off the rotary valve using the inside ring adjuster, just like that. And so now you won't cause any damage to the teeth because you've removed already the locked lock nut, and now it'll come out nice and easy, and there's no chance of you breaking that tool. Now, some people will choose to use a punch in here to try and get these this adjusting ring out. Now, the challenge with that is you can mar them, mushroom, and damage the threads, and the lock ring will not fit properly. Now, once you've backed it off, if you want to use a screwdriver to simply turn it around, that works just fine, but you're not hitting it with a hammer, causing any damage. So you remove this adjusting ring from the rotary valve. And at this point, we can simply lift up the rotary valve. All right. Inside there, we will see a Torrington bearing or a radial thrust bearing. So you can remove that bearing just like that. And then your seal is just on the inside. Now, to remove the seal, you can follow your manufacturer's instructions and use your socket, drive the seal out, and then drive your seal back in if you didn't already use the hydraulic method of removing your seal. So we can actually see this valve is centered. And if I grab our 3/4 inch 12 point again, as the operator inputs force, what actually happens is it'll deflect through that torque rod that's inside of here. And the torque rod is actually pinned right there. You can see that little dimple. And so what'll actually happen is that we deflect that torque rod. Let me just remove this housing from the vise, and I'll install the rotary valve just inside there to show what's happening. We're just going to soften the jaws. I don't have my aluminum soft jaws here, so we'll just use a cloth to prevent some marring on there. And we just want to hold it just enough to show you what's happening in this rotary valve. Remember that the torque rod is pinned right there, And so as we input force, it's actually going to twist and deflect and pull on that torque rod. So we got it pinned here, torque rod's going up and down, and it's going to twist. And as it twists, we'll actually see these gaps move back and forth. Those moving back and forth are opening and closing the hydraulic valves for our pump pressure to come in and be directed to the proper side of our rack piston. So let's just take a look at that deflection that happens with the steering wheel input. Just like that. So you can see a little bit of deflection. Let's turn the wrench the other way. And so just like what's going to happen, so we're going to let it spin on the cloth in the vise, but just like what would happen when you're driving down the road, the operator's input is coming in to the input shaft right here, and it's going to turn or twist that torque rod based on road feel, how hard it is to move the steering wheels. If the steering wheels are hard to move, or the front wheels, the steer axle wheels, if they're hard to move left to right, what'll happen is the force required to move them left and right will go up. When that force goes up, the resistance here to the shaft causes the torque rod to twist. When the torque rod twists in there, what'll actually happen is we will open up the valve. When the valve gets opened up, hydraulic pressure gets sent to the rack piston, and now the rack piston is going to assist the mechanical motion of the worm shaft in the ball nut. And that is how we get operator assistance only when the torque to steer the wheels is great enough. If there's no torque required, so let's say driving down the road at a high road speed, the wheels are quite easy to steer left and right. And so the operator's input is quite low, and we can see that valve does not deflect. But now put a little more load on that, make it in a parking lot or in a gravel road, and we can see it does deflect, and it opens up the hydraulic valve, and that hydraulic assistance goes on the rack piston and helps with the movement. So for the most part, with the rotary valve, if the operator has complained about the fact that the hydraulic assist is not operating, basically the only thing you can do with this rotary valve is clean it. Make sure that it's free of any dirt, debris. Make sure that the input shaft, this worm shaft right here, is actually in good condition. So that means we don't have any spalling, any pitting, any evidence of wear. So that would be cracking, grooves, anything like that in here. We want to make sure it's free of rust so that it hasn't had water running through it. So we'll make sure that's nice and clean. We want to make sure that our bearing surface, where our radial roller bearing mounts to, is nice and clean and free of any damage and debris. And then we just want to make sure that our bearing surface on this side as well is free of any damage. And then cleanliness, just make sure it's nice and clean. The seal surface, your actual seal, sits right here. And so again, you just want to make sure your seal surface is nice and clean. So take a non-abrasive pad and just clean that up and make sure that there's no damage there. Now, for the most part, it's likely serviceable and reusable. You can put it back in. If it's not, of course, you'll just buy a new one. So when you're reassembling this rotating group housing, making sure we replace all our seals, including this one right here. But when we install this O-ring down in the base, we're going to install the O-ring. That's fine, pretty normal. Make sure it's lubricated with like fluid. And then we install this little plastic ring. And if you're wondering what that is, that's a backing ring to make sure that the O-ring doesn't split away. So we put the backing ring down there to make sure it holds the O-ring in place. And there you go. Now your seal is fully assembled. And we never use a cast housing like this to put a bearing on. So we're going to give it its bearing race side, just like this. And we install our radial roller bearing, just like that. And now we install our input shaft. And again, our radial roller bearing. And our bearing race. There you go. And now we can go in and turn this adjuster and follow the manufacturer's spec to make sure we turn this down. Now on our adjusting tool, there is a place for you to install a torque wrench, and so that as you're turning this in, and you're going to line that up and you're going to turn that adjusting ring down, you have the ability to actually torque it to spec. So this is not simply adjusted by good and tight or a feel spec. This is something you'll follow the manufacturer's sequence. You'll set it, you'll seat it, then you'll back it off. Okay, notice I don't even have the lock nut on yet. Back it off a half a turn. Okay, at that point, you'll check your rolling torque, you'll make your adjustment. So any adjustment that needs to be made, you'll simply adjust it by installing this tool, and you will tweak it one way or the other. So you'll do that. We should install at this point our lock ring, just like this. So now your lock ring just being there is good to snug it up. All right, so now that you think you've got it adjusted, you've set it just right, you've used your tool, now what you're going to do is you're going to remove this housing from the vise. You're going to install it sideways. And now you're going to go back, or you're going to grab your dial torque wrench. You're going to make sure it's zeroed. You have your 12-point 3/4 socket. You're going to follow the manufacturer's spec, and you're going to check the rotating torque, reading the face of the dial indicator to make sure that your rolling torque is correct. If your rolling torque is too high, you are going to back off the adjusting ring with this tool. So you'll back it off to lower the rolling torque, and you'll turn it clockwise to increase the rolling torque. When you've set it to the manufacturer's spec, you will then grab the combination of both of these tools, and they actually fit together just like this. So one goes inside the other. And holding the inner, not applying any force to it, holding and only holding the inner, you will then put your torque wrench on. The adapter right here has got a square drive, half-inch square drive for you to put your torque wrench on, and you will simply turn it and you will torque it using your torque wrench. So we can back this off to show you right here. And so now you will install your torque wrench. And torque it until it clicks. At this point, your rolling torque of your input shaft has been set to make sure that there's no slop in there. And now you're ready to reassemble the rest of your steering gear. All right, one of the checks that you need to perform when servicing or inspecting or rebuilding a steering gear like this is actually checking the preload on the sector shaft. And so the way we'll do that is actually using a dial torque wrench, an inch-pound dial torque wrench, a 3/4 inch 12-point socket on the input shaft, and we'll actually be sure to turn this. And now the instructions in the service manual are clear to say do not turn this more than 1.5 rotations in either direction, or if you've just rebuilt this, you can actually be pushing the poppets further than they need to be. And so we want to leave those poppets in their reset position for when we reinstall the steering gear. So don't turn it further than 1.5 turns until the steering gear has been installed. But the way we'll check for the rotating torque is actually reading the gauge, making sure you're reading the correct side for either inch pounds or Newton meters, whichever side you're more familiar with. making sure you zero your dial indicator before you've installed it. Once you've installed it, make sure your 12-point socket goes on to the 3/4 inch at 12-point onto the spline. And all you're going to do is rotate it. Now break that initial torque, and as you rotate, you're simply going to read the needle position on the face. Now we'll turn it 1 whole revolution, and we can see that the sector shaft has turned. Now we can go ahead and turn it in the other direction. Again, you would have to reset your dial indicator face, and you can turn it now 2 revolutions in the other direction. 1 revolution will center it, just like this, and now the other revolution will show you that preload going 1 more turn. Now what we would expect to see if our steering gear is in good condition and the rack piston and sector gear are not wore out is that we have a high point. So as we come to the aligned mark where our sector shaft lines up center to the center mark of our cast housing, we would expect our torque to increase a little bit on our rolling measurement. So as we rotate it, we read. As we come close to that center position, and as we pass through center, and then we should expect to see that the torque goes down a little bit. So we would again compare our reading against our manufacturer's specifications. Now, if it's incorrect, there is an adjustment that can be done to bring it back into spec. All right, let's go through this final adjustment after we've reassembled the steering gear. So assuming you've already done the adjustment as per the manual of the input gear's rotary valve, then we've reassembled the rotary valve assembly into the main housing. We've reinstalled the sector shaft. We've reinstalled the rack piston, obviously, before we installed our rotary valve. We've put the rear cover back on, and now we're just getting ready to do our final adjustments. So as we can see in the final adjustment, it says to center the steering gear, rotate the input shaft, the valve worm assembly, until the timing mark on the end of the sector shaft is in line with the timing mark of the housing. So that's this one right here. So we've already done that. We've lined up the sector shaft in line with the center mark of the housing. Again, if that wasn't correct, you would simply take your 12-point ratchet, your 12-point wrench, and you would simply be able to turn it. And as you turn that, it's going to move your sector shaft, and we can just simply line it back up into the center position. So that takes us to step number 2. Step number 2, with an adjusting screw jam nut loose, turn the sector shaft adjusting screw clockwise to provide 45 to 50 inch-pounds, or 5 to 5.5 Newton meters, of torque required to rotate the input shaft valve worm assembly through 1/2 turn each side of the center. So what that is talking about is this adjusting screw right over here. So if we take a look at this adjusting screw right here, we see it has a lock nut and it has a slotted screw to it. So we would be able to unlock the lock nut and simply turn the adjusting screw. Now as we turn the adjusting screw in, so we make sure our lock nut is backed off, as we turn our adjusting screw in, we are going to be able to change our torque on the preload. So let's start with this backed off. And as we back this off, I backed it way off. Okay, so just assuming it was nowhere even close to where it was supposed to be. So if we backed off our adjusting screw, we can take a look at what our rotating torque will be. So let's grab our dial torque wrench again, make sure it's zeroed, put it on, and we'll go 180 degrees in either direction. Well, right now, in the one direction, if I use my little indicator, if I try and cheat that way, it looks like we're reading only about 18 inch-pounds. Well, it says we need to turn that adjusting screw until we got between 45 and 50 inch-pounds. So let's do that. Let's come back here to our adjusting screw, and now we're going to continually be turning it in, grabbing our dial torque wrench, and giving it a check. So we've turned it in a little bit, we're still only at about 18. So let's keep turning that in. So turning our adjusting screw. And now I know I backed it off a long way. So I'm just going to turn it in. And again, reset back to the center position and turn it 180 degrees through. That 180 degrees is measured. It's a half a turn of your input. All right, so we're going to turn it back through center, our half a turn. So we're going to get that ready. Turn it back through, and we still really haven't gone up at all. So let's keep going. Right through center, we get to, okay, this one went all the way up to 50 now. And we'll notice as we go through center, it goes down. So I'm just going to turn this back through the center position a half. So now we're going to check that one more time. We're sitting at 30, turning all the way through. As we get to center, it should go up. And it's climbing to 40, 50, 52. All right, so as we went through center, we got 52 inch-pounds. So we're going to back this off just a little bit and turn it back in. Okay, so always when you're making an adjustment, try and make your adjustments while you're turning in. So let's give that another check again. Let's back that all the way up. And let's turn this through center. And again, we'll see the torque increase as it comes through center. So now I'm at 40, 50. All right, so now that we've been able to make some of our adjustments by turning in our adjusting screw to get to the 45 to 50. All right, so we're going to turn this through. We're going to read as we turn, so 30. And what's going to happen is it's going to get greater as we come through center. So 30, 40, 50, just at 50, and then it comes down as we pass through center. So that's exactly where we need it to be, somewhere between 45 and 50 as per our instructions right here. And so now it says turn the sector shaft adjusting screw counterclockwise, back it off, 1/2 turn. And note the maximum torque required to rotate the input shaft, the worm assembly through 1/2 each side of center. So what we just finished doing was really sort of seating the sector shaft gear or the sector gear against the rack piston to 45-50, and now what it's saying is back off our locking nut, make sure we have enough room there, and we just want to back off this adjusting screw 1/2 a turn. So that's where we're going to go, 1/2 turn backed off. And at that point, if we want, we can sort of just snug up the lock nut. We won't tighten it up quite yet. And that takes us on to the last step. And now it says adjust the sector shaft adjusting screw clockwise to increase the maximum torque. So we back this off a 1/2 turn. And now what it wants us to do is check the rolling torque one more time. So the greatest torque we see there as we pass through center is 20. So what it wants us to do is it wants us to increase that maximum torque by 7. So what we're going to do is turn this up and snug it up just a little bit, turning that adjusting screw clockwise until we get 27 inch-pounds measured at the input. All right, so now we've snugged that up. Now once again, we're going to turn this through center. And we're going to look for 7 inch-pounds more than we got, so we're looking for that 27 number. There we go. So we've got our 27, 28 inch-pounds as we come through center. So what we notice is that as we back up from center, it gets lighter. As we come through center, the torque increases as we pass through center, and then it gets lighter again. That is that high point check of a steering gear. So what's really important is that our steering gear is never loose. It's never floppy. So if you were to grab your input or your 12-point wrench or ratchet, that you wouldn't have free play between the input shaft and your sector shaft. So that should always be under tension. It's not very much tension. It's only 27 inch-pounds of rotating torque right now. but it's always under tension. And so we can never have a steering wheel that moves back and forth without moving the sector shaft. There always has to be that direct connection from our steering gear to the sector shaft. Now, because both the sector gear and the rack piston are in mesh and the sector gear is actually tapered, what can happen as they wear is we do exactly that. We get end play between our input shaft, and the steering wheel seems to wobble back and forth, and there is zero movement at the sector shaft. So every time you move the steering wheel, even a little bit, you should see this sector shaft wiggling just a little bit. There should not be any end play between those two conditions, and that's the preload check we just did on this final adjustment.